We're going to start section 2.6. This is the last section we're going to cover in chapter 2. At the end of the year we will come back for section 2.7, but this will end chapter 2 for us for now, and this is the combination of functions. In the first video we'll do the easy stuff, the add, subtract, multiply, and divide functions. Tomorrow and in the next video we will do the composition of one function with another. So let's dive into the easy stuff. Just as two real numbers can be combined by the operations of addition, subtraction, multiplication, and division to form other real numbers, two functions can be combined to create new functions. For example, the functions given by f of x is 2x minus 3 and g of x is x squared minus 1 can be combined to form the sum or the difference, product, or quotient of those two functions. So, sum, difference, product, and quotient of functions. Let f and g be two functions with overlapping domains. Then for all x common to both domains, the sum, difference, product, and quotient of the two functions are defined as follows. If we have the sum of two functions of x, it's just f of x plus g of x. Or the difference, f minus g of x is f of x minus g of x. If we multiply, f times g of x is just f of x times g of x. And the quotient, f divided by g of x, is f of x divided by g of x, as long as g of x does not equal 0. So when we do come to these quotient functions, always got to worry about that denominator equaling 0. So here in example 1, we're going to do the sum of two functions. Just going to add them together. Given f of x is equal to 2x plus 1 and g of x is x squared plus 2x minus 1, find the sum. And after we find the sum, we're going to evaluate it at an x value of 3. So f plus g of x is, we just add them. F of x goes first, 2x plus 1. And then we add to that g of x, x squared plus 2x minus 1. And because these were two separate functions, I could have put them in their own sets of parentheses. But since we're just adding, those parentheses aren't really necessary. And now that we've written them both out, here's f of x plus g of x, we can combine any like terms. So we only have one x squared term. We have a 2x and a 2x, that adds up to 4x. And the plus 1 and the minus 1 cancel out. So there's our sum. F plus g of x is x squared plus 4x. And we want to evaluate that sum at x value of 3. So f plus g of 3 is equal to 3 squared plus 4 times 3, which is 3 squared is 9, 4 times 3 is 12, and if we add those together we get 21. 21 was our final answer, and we plugged a 3 through both functions. Let's see if we could have done that separately. What if I had plugged a 3 in for that x? So that would be 2 times 3 plus 1. Oops, I got my parenthesis in the wrong. 2 times 3 plus 1. And we're going to add to that the other function. If I plugged a 3 in there, it would be 3 squared is 9 plus 2 times 3 is 6 minus 1. Well, here we have 6 plus 1 is 7 plus 6 plus 9 is 15. 15 minus 1 is 14. And 7 plus 14 is the same, 21. Here we just did it in two steps. We ran the same number through both functions and then added. And when we originally started, we added the functions and then put the number through those functions. So subtracting. Exact same two functions, but now we got to be a little more careful because we are subtracting. We want to find f minus g of x. So f of x goes first, 2x plus 1. And now we're going to subtract the g function. Here we do need the parentheses. We're subtracting g, which is x squared plus 2x minus 1. So now to simplify and combine the functions, we have to distribute the negative. So that'll be a minus x squared minus 2x plus 1. And then we can combine all like terms. F minus g of x is we have a negative x squared. 2x and the minus 2x will cancel, and we have a plus 1 and a plus 1, which becomes a plus 2. There is our subtracted function. And they also want us to evaluate at an x value of 2. So f minus g of 2 is going to be, now careful here, that negative isn't with the 2, it's part of this function. So it's going to be negative something squared plus 2. And that something is, we're running a 2 through the function. So the 2 squared is 4, and that negative comes along then, so it's a negative 4 plus 2, which is negative 2. We could have found that same answer by plugging the negative 2 into the f function and getting that value, plugging the same negative 2 into the g function, getting that value, and then subtracting them after the fact. Next up, multiplication. We're going to multiply the same, or no, we got different functions this time. F of x is x squared, g of x is x minus 3. We want to find f times g of x and then evaluate at 4. So f times g of x is going to be our f of x function times our g of x function. So we distribute the x squared. X squared times x is x to the third, minus x squared times 3 is minus 3x squared. There is our multiplied function, f times g of x. Now we're going to plug a 4 in there. F times g of 4 equals 4 to the third minus 3 times 4 squared. 4 to the third is, well, 4 squared is 16 times 4 is 64, minus 4 squared here is 16 times 3 is 48. 64 minus 48, is that 16? Yeah, 16. So equal to 16, final answer. Here in example 4, we're going to do the quotient of two functions, and first we're going to do f divided by g, and then we're going to flip it over and do g divided by f, and we'll also talk about the domains of each. So first, let's do f divided by g of x. So the f function goes on top, square root of x, and the denominator we have the square root of 4 minus x squared. Now, if you did want to write that under one big radical, since they're both square roots, you could just put those under one bigger radical. And that would be fine, but it might be easier to look at the domain from keeping it as two separate radicals. So now think about the domain. What values can x take on without violating a rule of math? So in the numerator, we have the square root of x, and the domain of the square root of x is x must be greater than or equal to 0. In the denominator here, we have a radical and an x value, and we don't want that to ever be equal to 0. The denominator can never equal 0, and we never want a negative under that radical. So usually we take what's under the radical and set it greater than or equal to 0. But now we can't have the or equal part in it, because it is a denominator by itself. So if we solve this, we add x squared to both sides. 4 must be greater than x squared. And then we take the square root of each side, plus and minus 2 greater than x. So that's just telling us x has to be between 2 and negative 2. So x must be between 2 and negative 2. So we had our other domain from 2 to negative 2. And I'm using parentheses, remember, because I don't want the actual value of 2 or negative 2 in there, because that would make our denominator equal to 0. So now we sort of got to see where these overlap. And when I think about these overlapping, I always like to think about a number line. So for x greater than 0, I have 0, or it's greater than or equal to. I'm going to have a colored in circle at 0, and my arrow's going positive. For the second part of that domain, 2 to negative 2 with those endpoints not included. So negative 2 would be here as a parenthesis, positive 2 would be here as a parenthesis. Where do these domains overlap? Well, right along here. So the domain of f divided by g of x is bracket 0, comma, 2 parentheses. All numbers between 0 and 2 with 0 included. 2 is not. If we did include 2, that would zero out our denominator. So that's f divided by g of x. And let me just write that over here. Maybe I can do the next part without erasing it. Now we're going to flip it over. G divided by f of x. I'm just going to turn this upside down. The square root of 4 minus x squared divided by square root of x. So the domain of the numerator is going to be the same as what we found here, but here it can equal 0. You know, we can have a numerator of a fraction equal 0. It's the denominator we're worried about. So the domain of the numerator is going to be negative 2 to 2 with brackets, not parentheses. You know, the parentheses were to keep this denominator from going to 0. Now we're not worried about that. So we're going from negative 2 to 2 with our numerator. Our denominator are all x values. When this was in the numerator, we said greater than or equal to 0. Now we just want greater than 0 because we can't have our denominator equal 0. So let's see where these domains overlap. If I draw a number line, I'll put 0 in the middle. We're going from 2 to negative 2, brackets this time, 2 to negative 2. And now we're saying all x values must be greater than 0, not or equal to. So we would have a parenthesis at 0, and we're headed this way. Where do those domains overlap? From 0 to 2. Sort of like above, but now we're going from 0 to 2 with a parenthesis at the 0 and a bracket at the 2. So reversed from what we saw above. Got to be extra careful figuring out these domains, especially with these, and in the next video when we do the composite functions. The domains take a little thinking. So here's some practice problems. In the Huddle, you're going to do, for number 11, f of x and g of x are given. You're going to find the sum, the difference, the product, and the quotient. F divided by g, find the domain of that. For numbers 20 and 24, you're going to find the indicated values. You're going to do f plus g, and then run a 1 through that composed function. And f times g, and then run a negative 6 through that function. So pause the video, try those problems, and then start it back up and see if you got the correct answers. So let's see here for 11 part A, we want to find the sum, f plus g of x. So we're just going to take the f of x function and add to it the g of x function, x squared minus 4x minus 5. And that's it. Letter B. Now we're going to subtract the difference, f minus g of x. So again, we just start with the f function first. Now we're subtracting, and we're subtracting a quantity. So we do want the g of x function in its own set of parentheses. And then we distribute the negative. X squared minus 4x plus 5 is our difference of those two functions. And let's see here, next letter C is multiply. F times g of x. So f of x goes first, times g of x, 4x minus 5. And we distribute. X squared times 4x is 4x to the third. Minus 5 times x squared is 5x squared. And there's our multiplied function. Last one is a quotient, letter D. F divided by g of x. So f of x goes on top, x squared. G of x, 4x minus 5, goes in the bottom. There's our composed or our quotient function. And what would the domain of this be? Well, we have no radicals, so we don't have to worry about positive numbers under even radicals, but we do have a denominator. And to find our domain, we want to set the denominator not equal to 0, because we never want to divide by 0, and we add 5 to each side. 4x cannot equal 5. Divide by 4. X cannot equal 5/4. Any other number is fine. And I guess we could use a little set builder notation. You could say x is an element of the real numbers such that x does not equal 5/4. That's our domain. Any other number is fine. Okay, here we're just going to do a quick sum and product, and then we actually evaluate that function. First, we're doing f plus g. So f of x is x squared plus 1, plus the g of x function, x minus 4. And we could combine our like terms and get x squared plus x minus 3. That is f plus g of x. And now we're just going to plug a 1 through there. We're going to do an f plus g of 1. So that's going to be our composed function here is something squared plus something minus 3. Now we're just putting that 1 in. 1 squared is 1, plus 1 is 2, minus 3 would equal negative 1. And they want us to do the product. And after we do the product, to run a negative 6 through there. So our f of x function is x squared plus 1. Our g of x function is x minus 4. And we could do a little foiling here. We're going to have x to the third minus 4x squared plus x minus 4. There is our product function, f times g of x. And now we're just going to plug a negative 6 in there. F times g of 6 is, or negative 6, excuse me, is going to be negative 6 to the third minus 4 times negative 6 squared plus negative 6 minus 4. And let's see what we get here. Get that out of the way. Negative 6 to the third, negative times negative is negative. 6 to the third is 216. Inside these parentheses, let's see, we're going to have negative 6 squared is positive 36 times 4. The minus 4 will be minus 144. Plus a negative 6 is like minus 6. And then minus another 4. And that all comes out to a negative 370. Negative 370. There we go. And the assignment to go with these example problems, page 234, 5, 6, 13, 19, and 21.